Hi guys, I'm back again. I think I'll take this last program that we did, which was just void, and I'll use the next set of elements that I want to actually describe. So this one, I think we'll call this one logical operators, and I'll explain what the logical operators pretty much do. So here's what our logical operators do. Basically, we want to be able to check for logic. So our logic pretty much is the following: we've got an AND, we've got an OR, we've got a NOT. So this becomes part of our logic to say, can we work with a NOT? Can we work with an AND? Can we work with an OR? Why do we want to work with the two? We want to be able to say at any given point in time, we want to be able to compare two values. So we can say A and B. We can say A or B, or we can say A and not B. That's pretty much what we want to work with our logical operators. So we'll still work with this void main, but we'll add our variables. So our variables will be as follows. We can have int A and B, like we had previously spoken about. And then we initialize the two. A becomes equal to 7, and then B becomes equal to 8, like that. So what we then want to do is we just want to put a simple if statement, and this if statement will then give us or show us how we can compare the two. Although this will work, but will not be something that we can pretty much use within a program. So as we go along, we'll actually get into something that we can use in programs and work with for our various programs. So we can simply say the following: A, we put a space, we put two values, and then we put B. So this is the logical operator for AND. We can do the same for the other values, which is OR and NOT. We simply put if, we open and we close brackets, A, or we put two lines, A or B. And then the last one would be NOT. So for NOT, we need to have another operator, which will not only be A or B. We need to say our condition A we put a exclamation mark, and we say A is not equal to B, like that. Sorry, the exclamation mark should actually come before our B, like that, so that we can be able to see what this is. So our printf should simply give us a true, because we want to say whatever we've put in the brackets is true, like that. So I can just basically copy and paste that in each of the elements, and we'll find, if we run our program, we'll be able to see that each of these elements is true, right? What if this was not true? That will be something that we'll work with at a later stage. So pretty much here's what we are saying in this particular setup. When we look at line 11, we've got we've got if, open brackets, A, space, and B. All we are saying is we're checking for the value of A and for the value of B. If that is what we've got, we get a true. we look at the second one, which is line 15. Line 15 says A, and we've got A in brackets, a space, those two straight lines. That pretty much stands for our O. Let me actually put comments to say that is O. And then the next one is, we're saying A is not equal to. Not equal to. Which then gives us the true values. So in other words, these are then our logical operators. Let's say we just want to see, since we are on these examples, we want to see what the opposite is. Let's say we don't have a value, right? Let's say the opposite is true. Let's say we change this part. We say B is not equal to B. What happens there? You then find now, because we have put B and B, we're comparing B to itself. So B is equal to B. So that is not true. So the true element goes away. But if we want to see that this is not true, we can simply put an else. And in that else, we'll simply then have a printf, which should read not true, so that we see how this works and what we can put for our code. So if I run it now, you then actually realize now, because I've put line 19, or I've changed line 19 to say B is not equal to B, this, instead of it being true, and we've got an else statement, it tells us that this is not true. So that's pretty much what we'll be trying to do with our logic operators. So guys, I'm actually realizing that with the arithmetic operators, I'd actually left out something. So I'm just gonna create a quick project. I'll join this to lesson 3. So we need to have the following elements. So this is part of arithmetic operators, and we're just gonna quickly do a quick program to show us how these operators work. So like we said, we just need to create our variables, which in this case can be z and y, and then we initialize these two. Z is equal to 7, y is equal to 15, like that. So we can be able to do the following with each of these values, right? So we can simply say, for example, z plus plus, okay? We can also say y minus minus, which simply then means we can put a printf for each of these. Printf, we want to see what the value of z is. So we simply say z is %d, we put a new line, and then outside of that we put our z, so that we see what would have done to our z. We also do the same for our y, and then our y is as follows. So we change that and we put y is equal to that. So if we run this program, we actually then get to see that after adding plus plus to the value of z, we get 8. After adding minus minus to the value of y, we get 14. So that's part of our arithmetic operators, or rather these are increment operators. So I can just put there and say increment operators, and then from there we can also have a divide what you call a divide operator, so to speak. We then want to say, if we want to divide 7 and 15, right? So let's say we want to get the modulus. We call it the modulus of our z and our y. We can then simply say the following, right? Let's say we just add another variable just for the sake of this example. Our variable is x, so we say x is equal to z modulus y, like that, which then means we should be able to get a value. What this then means is, if we get a remainder with that division, let's actually do it the other way around. If we get a remainder for that division, we should get only the remainder. So let's see what this gives us if we run it. And we say x is %d. We put a new line like that, and then we get the value of x. Right. So what this then means is we've got y modulus z, which then means if we divide 7 into 15, 7 only gets in once and leaves a remainder of 6, which is what our modulus gives us.